Question 3. The equation of the curve is such that dy dx is equal to that. Then the curve passes through this point here. But find the equation of the normal to the curve. Now we should know that if we have, let's say, the curve here, and then we have a straight line here that meets the curve at only one point, that is what we call the tangent. Okay? This is the curve. And then that line which is perpendicular to the tangent at the point of intersection with the curve, that is the one we call the normal. Okay? So, at P here, 2, 8, they want us to find the equation of the normal. We need to find the gradient. Remember, to find the equation of the straight line, you need to know the gradient, that is number 1. Then number 2, at least one point through which a line passes. So dy dx here is going to be equal to a half here. Wherever there is x, then we put this 2 here. Okay, then plus, this is 72, then divide by 2 to the power of 4. So this one will be a 1, and then 2 to the power of the 4 is a 16, right? So we have all of this together. What do we get? 1 plus 72 out of 16. We get our answer as 11 over 2. What we have gotten here is the gradient of the tangent, okay? So gradient of the normal, since these are perpendicular lines, gradient of normal shall be equal to -1 divided by gradient of the tangent. Remember, for perpendicular lines, m1 times m2 is equal to -1. So if you have gotten m1 as the gradient of the tangent, then m2 is going to be the gradient of the normal. So you just say -1 divided by that gradient of the tangent. So which will give us -2 out of 11. Now, using the general equation y minus y1, which is equal to m into x minus x1, we have this point 2, 8. That means we shall have y minus 8, which is equal to, our m is -2 over 11. Then x minus, our x1 is a 2. So when we open the brackets, y is going to be equal to -2 out of 11 of x. Then -2 times -2, that is a positive 4 over 11. And then when this one crosses, it becomes a plus. So that will be 8 here. And then that means that the equation of the normal here is going to be, first of all, this is 8 times 11. What do we get? That is 88. 88 plus 4. That will be 92. So meaning y is going to be equal to -2 over 11 of x, then plus 92 out of 11. That is that. And then find the equation of the curve as part B. That means we need to integrate, okay, the dy dx. We need to integrate what was differentiated. So y is equal to the integral of dy dx. And our dy dx is 1 over 2 of x, then plus 72, then x to the power of -4 with respect to x. You increase the power by 1, you divide by the new power, so you'll have a half, then x power 2, then divide by 2, not so? And then this one here, of course, will multiply. When those two multiply, we shall get a 4, not so? So we shall have a quarter x squared, then plus this is 72x, then to the power of -3 out of -3, okay? Then plus c, we need to put that arbitrary constant because we don't know that constant which disappeared when they differentiated, okay? And we are supposed to find that constant using a point that lies on the curve. So this is y is equal to a quarter x squared, then this one will be -24. So we can write -24. Then this one is, the power is negative, so I can take it down to be a positive. So I'll have -24 out of x to the power of 3, then plus c. Okay, then we can use that point P which lies on the curve. If a point lies on the curve, that means its coordinates must satisfy the equation of that curve. So y here is 8, and then wherever there is x, I'm going to put a 2. So this is 24, and then 2 cubed here, then plus c. So this will be 8. First of all, this one will be a 1. Okay, when it crosses, it will be a minus. Then here, this is 8. 24 divided by 8, you get a 3. So this is a -3. When it crosses, it becomes a +3. and this one will give us the value of c. So what is the value of c here? This one gives us a 7, then plus 3, that will be a 10. That means the equation of the curve is y, which is equal to x squared out of 4, then minus the 24 over x cubed, and then where there is c, I just replace it with a 10, and that is that.